Okay, Wildcats. Today we're looking at journal page 56, graphing more complicated rational functions. Example 1. Select the graph of the given rational function. If the degree of the numerator is 1 more than the degree of the denominator, find the graph's slant asymptote by dividing the numerator by the denominator. Also state the function's domain and range using inequalities, set notation, and interval notation. If your graph indicates that the function has maximum or minimum values, using a graphing calculator to find those values to the nearest hundredth when determining range. Okay. So our function is f of x equals x minus 3 divided by x plus 3. Find the vertical asymptote by setting the denominator equal to 0. So we said x plus 3 equal to 0. Okay, we're going to subtract 3 from both sides. So then x equals negative 3. So there's a vertical asymptote at x equals negative 3. Okay, step 2, divide. Okay, so when we divide x plus 3 divided by x minus 3, or divided into x minus 3, we ask ourselves, what do you multiply x by to give you x? The answer to that is 1. Since the numerator and denominator have the same degree and the leading coefficient of each is 1, so there's a horizontal asymptote at y equals 1. Okay, so let's move on to the next step. Okay, step 3. Find the x-intercepts by setting the numerator equal to 0. So we set it equal to 0 and solve, so we add 3 to both sides. So then x equals 3. So the x-intercept is at x equals 3 or 3 comma 0. Okay, so step 4, we're going to graph f of x equals x minus 3 divided by x plus 3. Okay, before we do that, we can go back to our asymptote. I'm sorry, yes, is x equals negative 3. So let's graph that first. Okay, so we come here to negative 3, and then we have an asymptote at, which is a vertical asymptote, at x equals negative 3. Okay, all right. Now we also have an x-intercept at 3 comma 0. Okay, so that's 3, 0. We have a point here. Now there's also a horizontal asymptote. It says at y equals 1. Okay, so let's graph that. So y equals 1. Okay, and that's your asymptote at y equals 1. Okay, so since we already have a point between these asymptotes, we know our curve here is there. Okay, and it might be a little hard to see that, so let me do that in yellow. Okay, so let's graph f of x equals x minus 3 divided by x plus 3. Okay, now all we need to do now is graph this and find out a point either above or below the horizontal asymptote, and we'll have our curve. So let's do that now. Okay, so we're going to go to on, new document, add graph, and then we're going to do control divide x minus 3 divided by x plus 3. Okay, so I'm actually going to press control T. We know we have an asymptote. Okay, so we can pick any of these points to the left of negative 3. Honestly, negative 4, 7 is perfect. Let's graph that point. Okay, so let's use the point negative 4, 7. Okay, so now negative 4 up 1, 2, 3, 4, 5, 6, 7. Okay, that tells us our curve is right here. Okay. All right. So there's your graph for step 4. All right. Now let's look at step 5. Okay. Find the domain. The inequality notation is x is less than -3 or x is greater than -3. That's because you have a vertical asymptote at x equals 3. Set notation is x such that x does not equal -3, and interval notation is -infinity to -3 not included or not including -3 to infinity. Find the range. Inequality notation is y less than 1 or y is greater than 1, and that's because you have a horizontal asymptote at y equals 1. Set notation is y such that y does not equal 1, and interval notation is -infinity to 1, not including 1, or not including 1 to infinity. Okay, we would go and update step 5. All right, take a look at example 2. Select the graph of the given rational function. If the degree of the numerator is 1 more than the degree of the denominator, find the graph's slant asymptote. By dividing the numerator by the denominator, also state the function's domain and range using inequality, set notation, and interval notation. If your graph indicates that the function has a maximum or minimum value, using a graphing calculator to find those values to the nearest hundred when determining range. Okay, so our function is f of x equals -3 parentheses x minus 2 divided by x minus 2 times x plus 2. Step 1. When a rational function has a factor in the denominator that is also in the numerator, a point of discontinuity occurs at the value of x, for which the factor equals 0. And what they mean by that is x minus 2 divided by x minus 2 divides and becomes 1, so you're left with -3x divided by x plus 2. So we now know that there's a hole at x minus 2, so we need to set x minus 2 equal to 0 and solve. So we add 2 to both sides. So then x equals 2. On the graph of the function, a point of discontinuity occurs as a hole. So there's a hole at x equals 2. But we need to know the point. So we're going to plug x equals 2 into this to find y. So y equals -3 times 2 divided by 2 plus 2. Okay? So -3 times 2 is -6 divided by 4. Okay? Well, that reduces to be -3 divided by 2. So your point of discontinuity is 2, comma, -3 divided by 2. I'll also say the whole, the point of discontinuity, the whole is at 2, -3 divided by 2. Okay? All right? Step 2. Find the vertical asymptote by setting the denominator equal to 0. Okay? So we said x plus 2 equals 0. Subtract 2 from both sides, so x equals -2. So there's a vertical asymptote at x equals -2. All right, go and finish up step 2. All right, step 3. Find the x-intercepts by setting the denominator equal to 0. I'm sorry, the numerator equal to 0. So we set the numerator equal to 0 and solve. So we divide -3 by both sides. Well, so then x equals 0. So there's an x-intercept at x equals 0, or the point 0, 0. Okay, so step 4, graph f of x equals -3x divided by x plus 2. So first, let's go ahead and graph our hole, which is at 2, -3 divided by 2. Okay, which, let's go ahead and use a calculator to find out what that is as a decimal to make it easier. So I'm going to come over here. I'm going to go on new document, no. Add calculator, do -3 divided by 2, press Control Enter. That's -1.5. Okay. Graphing 2, -1.5 is a little bit easier than graphing 2, -3 divided by 2. So let's graph that whole. Okay. So we come over here. 2, -1.5 is between 1 and 2. So we're going to put an open circle That's whole at that point. Okay. Now the next thing we're going to do is we're going to graph the asymptote, which we have at x equals -2. So we have a vertical asymptote at x equals -2. Okay. All right. Now we don't see the horizontal asymptote, and we can find that by graphing this in the calculator. So let's do that now. Okay. So we're going to go to on, new document, no, add graph, and then we have control divide -3x divided by x plus 2. Okay. So then I'm going to click on that, delete this. We don't need that. I'm going to go to menu, menu, view, grid, line grid. Okay. Move this over. Okay. And I think you can kind of see here that if I count the tick marks, that's -1, -2, -3. And then you can see here that something's happening at 1, 2, 3, -3. And you can even come over here and you can see it's getting close to there. So we can see we have an asymptote at -1 to -3. Okay. And let me go back to it. Yep, -3. Okay, so we have a horizontal asymptote at -3. Okay, so that's y equals -3. Okay, and then this is x equals -2. Okay, all right. Now our x-intercept is at 0, 0, which is here. Now we have our point in our hole, so our curve we know is going to go here. Okay, and let's graph that in yellow. Okay, now we need to graph this in the calculator, which I think we already did. And we need to pick a point to the left of -2 to find out if it's above or below the horizontal asymptote. Okay, so here I'm going to press Control T, and let's go to the left of -2, and we can use the point -3, -9. Okay, so we're going to use the point -3, -9. Okay. All right, so -3, -9 is this point right here. Okay, so that point's really low, and it tells us our curve is here, but let's go ahead and pick a point maybe at -4, -5, one of those, and see if we get a better point from a graph. So -4, -6. So -4, -6 is right here. And so you now definitely know that the curve is going to go like that. Okay. Okay. All right. Go ahead and finish up the graph for step 4. All right. Let's take a look at step 5. Okay. Find the domain. Inequality notation is x is less than -2 or -2 to 2 or x is greater than 2. Okay. Set notation is x, so I said x does not equal -2 and x does not equal 2. Interval notation is x is -infinity to -2 or -2 to 2. And remember, parentheses means it doesn't include, or 2 to infinity. Step 6, find the range. Inequality notation is y is less than -3 or y is greater than -3. And set notation is y such that y does not equal -3. And interval notation is from -infinity to -3 or from -3 to infinity. Okay, go ahead and finish up step 5. and have a wonderful Wildcat day.